All right, hello. So I want to introduce some concepts for this central net force module. And the first thing I want to do is suggest a little experiment that you can do at home. This is a concept where there's some very tangible things that you can feel if you actually try this. So first thing you'll need to do is find something with some mass, ideally not something breakable. I've got a little Yoda toy here. And then I've got a string tied to them. Now for this you're going to want to get somewhere where there's not too much around you, because what you're going to do is swing this around. And be careful that you don't hit anything, that you don't hit yourself. I don't want anybody getting injured as a result of physics distance learning. Now what I want you to pay attention to is how firmly you have to hold the string to keep whatever you're spinning going in a circle. And you can play with some things. You can play with some things like how fast you spin. You can play with some things like how big of a circle you spin it in. Do you spin it in a big one versus a small one? You can even try a heavy object versus a light object, though again, especially if you try some heavy objects, be careful. I don't want anybody hurting themselves. And like I said, I want you to pay attention to just how difficult it is to hold the string. So if you spin your object faster, does it get harder or easier to hold the string? If you spin it in a circle with a bigger radius, what happens to how difficult it is to hold the string? Now, next thing I'm going to do is we're going to use this scenario of Yoda spinning on a string to think through what's going on with the forces and define some terms. All right, I've switched over to my document camera view to think through the forces. So I've got a little diagram of Yoda spinning in a circle. And the first thing I want to do is an interaction diagram. So I've got Yoda, and Yoda is interacting with the Earth through a force of gravity, and Yoda is interacting with my rope, which exerts a tension force. All right, and then I'm going to define Yoda as my system. So now that I know what those forces are, I'm going to draw myself a free body diagram. So I've got the force of gravity going downward, and then that tension force goes along that rope. Now you'll notice I drew it at a bit of an angle. That's because I know Yoda's not accelerating up or down, and so those up and down forces have to be balanced. Now the last thing I'm going to do is draw a vector addition diagram to get a visual of the net force. So I can see that even if Yoda's not accelerating up or down, these forces are still unbalanced. And the way I drew this, my net force is pointed towards the center of that circular path. And so that's where the name of this model, the central net force model, comes from, is we have a force that points towards the center of a circular path. Now, let's go ahead and get a definition. So when we have one of these central net forces, we're going to call it a centripetal force. So a centripetal force is just an F net towards the center of a circular path. And so a centripetal force is not necessarily a specific force. It's more that it's a net force that's accomplishing a specific task. And so that's going to be a really important idea as part of this model. Now, one thing to think a little bit about is if you were to suddenly take away that central net force, what would you expect to happen to the path of the object? For example, if while I was spinning Yoda, I suddenly cut the string, what should happen to Yoda's path? You can check out the answer in one of the videos I have posted next in the module, where I've got one of those constant speed buggies attached to a string to force it to go in a circle, and I cut the string while it was moving to see what happens.